Temperature, pressure, space, radiation, electricity, sustainability. Human progress is based on materials. Starting on the level of atoms and molecules, innovation, technology, and prosperity are steeped in materials science.
Material science involves working with formulations, with composition, working with processes, temperature, pressure, and working with process engineering. It's understanding the combination of all of those sciences and using them to help manipulate products and materials into processes that deliver consistent products.
And that's what Lucideon, an independent materials science consultancy, does better than anyone, anywhere.
Lucideon is a unique, independent materials science consultancy operating on a global basis. We can solve very difficult challenges fast because we have 250 scientists who are both technically and commercially on top of their game. The importance of Lucideon in materials science is the application of the science vis-a-vis busy in-house R&D centers or research-focused academia. Time is of the essence to industry. And that's the reason why the science and the R&D needs to be driven by commercial facilities like Lucideon. Lucideon is a very diverse organization. We're able to combine a range of technologies, including biology, inorganic chemistry, materials science, to bring commercial solutions, not just scientific ones. We support and serve a range of sectors around the world: nuclear industry, aerospace industry, construction, healthcare. We work on a range of materials, so ceramics, alloys, superalloys, bricks, concrete, some of the basic materials of life. And with this, day in, day out, we are helping to solve some of the biggest challenges for society and industry around the world.
An obvious candidate for chief planetary challenge is climate change and net zero. Batteries, fuel cells, solar panels, affordable nuclear fission and fusion. In its quest to mastermind better materials for those applications, Lucideon focuses on ceramics, metals, and geopolymers.
There are a number of different things that we work on here at Lucideon that will enable net zero. Better coatings on solar cells, new battery materials or ways to produce them, or higher temperature coatings that allow engines to operate at a higher temperature and therefore more efficiently. One of the technologies we're looking at to support net zero is called flash sintering. Ceramics all begin their lives as powders, which means that in order to turn them into a useful product, you have to actually densify the material. Flash sintering is a technique that uses electric fields to accomplish that in shorter times and using lower temperatures, which makes the process more energy efficient. While flash sintering does allow for lower temperature sintering, its real advantage for net zero is as an enabling technology. So producing materials like batteries or nuclear fuels that have new properties, right? Properties that can't be attained in conventional ways.
As the only organization in the world to offer flash sintering on a pilot scale, Lucideon has been working on new nuclear fuels that are safer and more affordable than uranium.
That's a huge effort that's ongoing on our UK site right now. We've successfully demonstrated the flash sintering of not just mock fuels, but actual uranium dioxide pellets to basically sufficient densities, the kind of correct microstructures you're looking for. So that technology is really advanced to the point where we're ready to actually transition it into an industrial application. So we're working with partners like NNL and Orano over in Europe to actually integrate this densification technique into both the production and the recycling of nuclear fuels.
Other flash sintering experiments have explored the use of this technique to make the production of solid oxide fuel cells more efficient.
We were able to sinter over large areas of a solid oxide fuel cell material and prove to ourselves that it could potentially speed up the production of those cells.
Making industrial production more efficient would be a big deal for the planet, especially when it comes to ceramics and cement, whose production is massively carbon intensive.
Hydrogen may be the solution to less emissions, more effective, more productive technologies. Lucideon, with its hydrogen kilns, are able to use blends of hydrogen from 20% all the way to 100%. Hybrid kilns, hydrogen, natural gas, even with electricity, giving industry the chance to join the journey in a capital effective manner, while also cutting emissions for high pollution industry.
Some of the most exciting technologies rely on materials that need to work in horrible conditions, in extreme temperatures, radiation, or under awesome pressure. Lucideon scientists create groundbreaking new materials that are built for those harsh environments.
I think we'll use that in the furnace, the top hat furnace outside in the lab through there in the sintering area. Once we've done that, we can look at how it's performed and then see where we are and then take it on to the next stage for the trials next week.
Okay, that sounds good.
Lucideon excels at developing and testing materials for harsh environments. One example of this is our proprietary MIDAR and mallet systems. MIDAR is a low-temperature curing geopolymer system that enables us to be very flexible about how we approach materials. Our MIDAR technologies are developed within the laboratories. So we're blending powders, we're blending slurries, and we're blending reactants together to form a final material that can be cast, poured, or formed into the final product. Unlike cement, MIDAR doesn't involve a high temperature processing where we're actually having to heat the material up to well over 1,000 degrees. We're just working with cold-based materials, chemistries, solutions, and powders. They can even incorporate other materials and waste, so we can use waste brick products within those feedstocks as well. The properties of these geopolymers very often completely outperform traditional cement-based products. These applications can be used in a lot of different industry. Within the construction, we can make brick-like products, we can cast concrete, we can make them into wall panels, we can even use them for insulation foam. In particular, we've been developing them for waste encapsulation using nuclear waste, and what we're showing is that we can encapsulate a greater amount of material than the current solutions would have, which means saving money over the long term on storage.
Lucideon can not only make materials, it can break them too. Testing everything from submarine parts to orthopedic implants, Lucidion's experts push materials to their limits.
Mechanical testing means that we're evaluating samples to determine the mechanical properties of a material. So this tells us how strong a material is and how it might behave in our clients' applications. Our wear department tests orthopedic implants. Behind me, that's actually a simulator. We can put in actual constructs that are the same ones that can go into your body and do thousands of cycles where those constructs are moving just like they would in your body, and we can tell our clients about the behavior of their implants. Some of the most exciting projects for our scientists are failure analyses. We do failure analysis on all kinds of things, from implants that have failed in the human body and been removed, to rocket ship parts, to broken tools. We start with non-destructive testing before we move on to anything like cutting into the sample. A lot of times we can put it into our scanning electron microscope. We can actually look at the surface of a fracture or a broken part, and we can tell where it originated and how it broke. So if it broke really slowly, if it gradually broke apart in a repetitive process, or if it broke all at once and from which direction, just from looking at the surface under an electron microscope.
Here at Schenectady, we own and operate the largest stress corrosion and cracking facility in the world. We've amassed over 10 million test hours, and we have over 100 years of experience between all of our contributors, which establishes us as the gold standard in stress corrosion and cracking testing. SEC testing usually comprises of using a stainless steel vessel, simulating a pressure reactor, in which we then add a specimen, and we are adding continuous stress to the specimen. We add high temperature and high pressure during our experiments to simulate the passage of time to predict the susceptibility of the materials that we are testing. We often add different corrosive elements in the form of water chemistry to environmentally assist the crack growth and fatigue of the specimens. Here at Schenectady, we put our materials through extreme heat. At other US sites, we apply cryogenic testing, which is applying extreme cold temperatures to our materials. Our output for our customer is to understand what went wrong and how to fix it.
What makes Lucideon unique is that we have a materials research team and a testing and evaluation team that can work together under one roof. This makes it possible for us to solve even the most complex problems fast.
Lucidion's materials expertise extends to microbiology-driven testing and formulation. It's a powerhouse of applied research and testing for the FMCG, food, and cosmetics industries.
Many of the household products around us contain multiple ingredients. This mix of ingredients is known as a formulation. Toothpaste, shower gel, shampoo, even ketchup, all of these are formulations. Sometimes we need these products to either inhibit or completely kill microorganisms. To optimally produce such a product requires expertise in both microbiology and formulations. And that's exactly what Lucidion's IMDF team has. Our teams deliver integrated microbiology, imaging, materials, and formulation development, which enable true partnerships and bring value to our clients' R&D and product development projects. Within the labs you can see here, we provide inorganic and organic chemistry testing on gases, medical devices, construction equipment. Any organic or inorganic compound you can name, Lucideon has properly tested it.
But even with all the brains and technology that Lucideon has access to, researching new materials would be impossibly expensive if the thousands of combinations for a single application had to be tested in real life. And that's where computer simulation comes in. It's called impact, for good reason.
Impact is a broad term for Lucidion's use of computational tools and techniques. A great example of a way that we can use impact in a normal challenge is by using it to really define what a problem is and then focusing in on designing a solution to that specific problem, right? So we might look at a target area like environmental barrier coatings, look at kind of specifically what properties control that application. and then use first principles modeling, which is really fundamental materials modeling, to design materials that might work really well in that application. Impact makes a huge difference in the efficiency of experiments because you can consider thousands of materials and hone down on just a few that should actually have the properties you really need to be able to use them. It can be applied to a really wide range of end uses and products. So this can be anything from formulating a new ceramic ink for ceramic AM to designing new coatings for energy barriers, as well as to the newest nickel-based superalloy.
Materials research is the frontier of stunning new discoveries. With unmatched global expertise and technology, Lucideon is expanding that frontier every day.
Lucidion's not standing still, we're always looking further ahead. We're already starting to look at new areas, such as engineering biology, such as cell and gene therapy, technologies that will be critical not only in the 21st century, but in the 22nd century. At Lucideon, we make the world a materially better place.